welcome to Modern Scuba's YouTube channel. So this was some research that I'd started into our dive team being able to conduct their own visual inspections on our tanks. And I took my research and rolled it up into a presentation. So please, if you like this kind of content, like and let me know. So we're going to start off with scuba diving cylinder identification, and then we're going to move into the testing requirements. I'm going to go through 3 examples of different scuba cylinders. I'm going to show the markings and how to read the more important stuff. I'll go through most all of it, but the important stuff is what I really want to highlight. So first example I'm going to use is just a standard 80 cubic foot aluminum cylinder. You're going to see something along the lines of DOT-3AL3000, which is the important part. Then it moves into the serial number, the AS, all those X's, and then the M4002. Then you've got a hydro date, the manufacturer, the size, some specification information. And then the TC3ALM207, which I'll explain what that is in just a second. First, the DOT and TCs are for the regulatory authorities. That's US DOT and Canadian Transportation Authority. Then the 3ALM or 3AL is just what the material is. In this case, they are aluminum tanks. The 3000 immediately behind the 3AL is your service pressure and PSI, and behind the 3ALM is 207, which is your service pressure as well, but in bar, which is the metric unit. The AS whatever numbers are the serial numbers for that particular cylinder. The M number, this case 4002, is for Catalina. It's just the manufacturer's registration mark. As well, on our work tanks, we also have M5658, which is for SCUBA, and M4141, which is a Luxfer mark, from the best I can tell. Then we move into that 07C08. The C is actually a funnier symbol than the actual C, but that is our original hydro date. You can tell it's the original hydro date because it's in line with all of the other important information on the cylinder. This is kind of the born-on date for that cylinder. Then we move into Catalina. Catalina is actually a cylinder manufacturer, as well as SCUBA and Luxfer. S80 is the cylinder identification. S for scuba and 80 for capacity. On our work tanks, we also have it listed as S-80, SO80, XS80, and they're all just 80 cubic foot aluminum tanks. SP12, I've never seen this, or I've never paid any attention to this in any of our cylinders, but apparently that is the thread in the neck of the cylinder. So this is a typical aluminum 80 manufactured by Catalina in the year 2008 with a service pressure of 3000 psi. Next example is going to be a steel 100. This one's got Faber, made in Italy, M8303, blah, blah, blah. Then 01 star 14, then the Canadian information. Then down the bottom, you got DOT, SP13488-3442 PSI, then some REEXX, and then TP5250 PSI, XX Scuba, HP100. And this is also going to be stamped in the neck of that steel tank. So we got the DOT numbers and the TC numbers, just like the aluminum. Then you have the SP13480 or the SU7694, which is the special permit for the construction of the bottle or the materials, whatever DOT is determined is needed to identify what type of material and what the bottle is made for. The 3442 is the important number that we're going to see next, as well as the 237. These are the service pressures and PSI and bar respectively. So this tank definitely runs a good bit more pressure than the aluminum 80. And that's really what I wanted to have stand out in here, is that you've got to read these numbers so that you can identify what pressure you should be running at. This is the serial number next. The M number again is for Faber. It's the M8303. Faber, of course, is the manufacturer. 01*14 is the born-on hydro date. So this tank was made in 2014-ish. HP 100 is your cylinder identifier. It's a high-pressure 100 cubic foot cylinder. I didn't know this before, but the TP 5250 is the hydrostatic test pressure. I always just thought it was 5/3, which, I mean, that's going to be pretty close to 5/3, I would assume, without doing that math. Then you've got some extra, not lesser important information. The rejection, elastic expansion, I'm assuming is for the testing, the hydrostatic testing. Then you've got SCUBA as the distributor, and it was actually made in Italy. So this is an example of a steel high pressure 100 manufactured by Faber for SCUBA in 2014 and has a 3,442 psi service pressure. What I really want to stand out was this tank runs 442 psi higher than the aluminum 80, which you're going to have to pressurize it to 34, 40-ish, just so that you have your full 100 cubic foot. Now I'm going to go old school with a steel 72. So you've got DOT-3AA2250, and that's really the most important bit of numbers. So you got the DOT, or I found out they do also do a ICC, which predated the DOT markings for scuba tanks, and the 3A or 3AA, which just means it's a steel tank. And the service pressure is 2250. That is the nominal service pressure. And then you got some other stamped information, which I really wasn't sure about. And then the 3 funny character 69 plus. This is the original hydro date for this tank. So it was built in 69. And then they put the plus in, which means that you could overfill it by 10% to have a total pressure of 2475 psi in 1969. So this is a steel low pressure 72 built in 69 with a actual working pressure of 2475. And what I want to stand out about this is that's 525 psi less than the aluminum 80 that we use normally. The reasons that this is important is when you go to fill it, you probably don't want to run 3,000 to 3,400 psi fills on that 2250. And if you were to run 3,200 to 3,400 psi fills on that 100, when it cools back off, you're probably going to be below full tank. You're not going to, when it cools off, you're not going to have your full 3,400 psi. And that's, again, about the volume that you're going to have. And each tank is also going to carry a different, slightly different size, but it's also going to have different buoyancy characteristics. All right, so the reason why we test, we do 2 types of tests. We have hydrostatic testing and we do visual inspections. The reason why we test is things can go very bad, and when they go bad with 2,400 to 3,400 psi, they go very, very bad. These were just a couple of examples I could find really quick. However, whenever we had our shop back in the 90s, there was an old news article that got faxed around to everybody about a guy losing a whole hand due to a neck explosion. So hydrostatic testing is called for by Federal Code of Regulations. You have to periodically requalify the cylinders bearing DOT or TC numbers. Here's the chart of what you do to requalify them. For typical aluminum, it's going to be 5/3 of working pressure except for non-corrosive surface, and requalification for scuba tanks is at 5 years. For .3A, 3AA, and 3AL, which is going to be most all of your scuba tank configurations, you're going to have direct water jacket or direct expansion method. For hydro testing, each cylinder is tested to 5/3 working pressure, and it's got to come back within 10% of its expansion. So in hydrostatic testing, pretty much the way that they do it around here is they put the empty cylinder down into a vial, then they measure out how much water was displaced, Then they fill up to the testing pressure and measure how much that tank expands under the certain testing pressure. Then they let the air back, actually the water back out, and then they measure how much that tank returned back to its original size. You've got to have a certain percentage of its return back to its original size for it to pass. Now, in addition, the cylinder is made out of 6351 T6 aluminum has to have an additional testing. They're looking for sustained load cracking, and they want to do it in a non-destructive manner. And the way that they do that is through eddy current examination. So basically, they stick a little probe into the threads of the neck, turn it around, and they're looking for changes in the flow of the magnet or the magnetic pathway around the neck. Eddy current testing is only required on these 6351 aluminum alloy. Good news is Catalina says they've never used 6351. Their tanks have always been 6061, so no Catalina tank is ever required for eddy current testing at this point in time. Luxfer says that between 1987 and 1988, they got out of the 6351 business, and all of their tanks afterward would be 6061. So pretty much any Luxfer 1989 and up, you should not have to do eddy current testing until they decide that Federal Code Regulations wants you to. Visual is basically you just open it up and look at it. Visuals have to be performed with the CGA pamphlet C6 for steel and C6.1 for aluminum. These pamphlets are about 75 bucks a piece, and my research didn't cover that kind of cost, so I don't know what exactly those CGA pamphlets stand for and what all they have in them. But from doing it in the past, visual inspections were not that difficult. But you still have to inspect them, and you have to, they say, condemn or approve based on CGA criteria. However, they're clean, they're mostly shiny, you don't see anything major. We've never really ran into an issue in years past. Now, when we used to do this, I think we did our eddy current testing on every tank that was requiring of it with every visual on every year. We didn't do it just at the hydro date. I'm not sure if the place we were using even had the capability of doing that for when they do the hydro, but I think we just went ahead and tested them just for our own safety because we were most likely going to be the ones filling them. When you're doing the visuals, what you're looking for is anything in the tank that shouldn't be. Foams, liquids, smells. If it smelled bad without a bunch of air in it, it's going to smell really bad whenever you put a bunch of air in it. You're looking for corrosion and pitting, anything that looks like it may compromise the integrity of the sidewalls and bottom and neck. Really the big thing is if you keep air in it, you're not going to have too many problems. Liquids are non-compressible. They do sometimes have some evaporation. Petroleum can actually create a foam that builds like a white grease on the, usually we found it on the inside of the neck and up around the valve. When the valve come out and it was a little greasy looking, that was usually a sign that we had some other issues to look for. Luckily with aluminum, I've always been told it was self-sealing, so usually oxidation, corrosion isn't a big deal in aluminum, but you still want it clean. You don't want to be breathing aluminum oxide. Deep pitting can cause you to have to condemn your tank, so you do want to break those pits open, see how bad it is. If you are encountering oxidation, you probably want to check your air source for dryness. So to prevent problems that you'd normally see with visuals, just keep air in your tank. We, at one point, were doing, if you had below 500 PSI in your tank, when you brought it in for fill, we were popping the valve and just doing a quick visual. This was to make sure that nothing was able to come in past the valve. If, say, you have no pressure in there and you somehow rub a little bit of grease or grease drops into the tank when the valve is open or just sits in the valve prior to the seat, you could potentially get contamination inside the tank. But if you had pressure inside the tank, as soon as you open that valve, it's going to blow the contamination out and wouldn't be a problem. You do want to use an air source that is tested. I would recommend keep using the same place as often as you can and make sure that they show the certificate for their grade of air. And here's some additional resources that I use to come up with all this. We've got Electronic Code of Federal Regulations, the Compressed Gas Association. They look like they really want money for most of their help. Catalina has a pretty good support mechanism. Luxfer had a pretty good support mechanism. All this information was, most of this information was easily obtained from all of these sites. All right, so that is our cylinder tank identification and testing requirement. If you like this video, please consider giving me a like and a subscribe. And hopefully I can put out some more information like this soon. I've got an idea for doing another one of these videos just like this on fill station operation. That presentation is still a little ways out. Just barely started scratching at it. If you have any other ideas or anything you'd like to see, just let me know and I'll see what I can come up with. Thank you and have a great day.